Awesome. All right. Well, yeah, thank you, everybody. This is actually I think my first time since COVID happened. So we're back. We made it through, which is also really, really exciting. So thank you on the internet as well as that's joining virtually. Happy to have you and spend time with you today. And so what we're going to focus on today, a lot of it is like, what does it actually look like from, we have these ideas, these sustainability ideas from the public sector and also the private sectors. We're starting to hire, we're starting to see sustainability managers. We're starting to see chief sustainability officers from Fortune 500 companies. So now we have these goals and these ideas that we want to implement within our companies. What do we do? What are the steps to actually make these projects happen? And so, a lot of what we've seen is even at trade shows for these type of assets is we have these high efficient solar modules. We have new EV charging stations that can charge cars within 15 minutes, 20 minutes, 1 megawatt charging stations. Okay, great. That all sounds great. But how do we make it happen? Currently, energy prices are skyrocketing. When we model projects, we have to model projects from like almost a 5% energy escalator that utilities are increasing their prices by 5% almost every single year. So now if we're adding more energy load, essentially, which would be EV charging stations, we have a project with the Transportation Authority that goes, hey, Corbin, I want 10 150 kilowatt charging stations for our buses and fleets. So you're telling me that now instantaneously, we need to provide 1.5 megawatts worth of power for whenever you're charging. So there's faults sometimes where we have these ideas to do a project. We want to do these different EV charging station projects, but is there power available? Sometimes we go through the process of we get engineered, we get electrically engineered, we get structurally engineered. All of a sudden it goes to the city and then they just go, there's no power. We can't provide the capacity to feed the extra power needs that you have. So I want to talk about to try to create awareness of what it looks like from a step-by-step process to implement these projects, to try to make sure that we have the greatest chance of success to bring these all in. And as we learned from all these different presentations and Ashley, how this is such a collaborative approach. We have these new bills that are coming out there to help transfer our economy and our energy sectors to become clean, green, renewable. So we have to essentially be in this together to make sure that we do take the appropriate guidelines to make sure the funding is appropriate, and also we do these projects effectively and that are for the best cases essentially. So as we're going to dive into this presentation,
the first slide always get caught up.
There we go. We're not off to a good start. No. So a lot of it is, on the electricity standpoint, we talk about measuring and monitoring. And so of course we have to measure and monitor our electricity consumption if we're trying to reduce it. So from an energy and electricity standpoint, awesome. The fastest way we have these goals. So how do I become 100% clean, green energy? How do I do zero net energy? How do I create microgrids? I like to say there's, of course, on a power perspective, if we can model it correctly to have solar at night or any type of renewable generation during the daytime, and then if we have power outputs at night, which we see a lot, where some people go, my operating hours until 6 o'clock p.m., but there's so many wasteful assets that are still producing power. Those are still out there. And so if we can create battery storage at night to offset that, we can oversize our solar to essentially charge the battery during the daytime to have that battery storage at night. We can be able to create a full clean green energy solution at facilities and sites. And so a lot of ways to be able to do that is transitioning our power, stop burning fossil fuels, and we can hopefully transition our ways to using clean green energy sources through the solar and battery storage technologies. And a lot of this presentation is going to be about, mainly the assets of solar, battery storage, EV charging stations. A lot of it is, these are a lot of the directions that we want to move towards with the new bills that the White House has provided for the funding mechanisms. So we do want to focus on that a lot in this presentation, but there are other energy producing assets and products that are available. But for this case, we're going to talk about clean green energy and produced by solar, battery storage, and EV charging stations. So dive into a little bit of who is OneSource to know who we are, what we do, how can we collaborate, as well as to help this macro opportunity to help transition our economy and our energy sectors to become clean green energy. Market forces, what are we seeing? Solutions and goals. We're going to dive into what is a microgrid. There's a lot of misconceptions of what a microgrid is and how to get there. We're going to dive into I'm going to take a little mock facility. All right, this is a building. Now what do we do? What's step one? Now we see this building. What do we do? I'll talk a little bit about product if we have time, if we can, about just different, latest solar solutions, battery energy storage, chemistries and applications, and how do we use it, and also EV charging stations. And one thing I do want to say is, there was a big lawsuit happening about solar manufacturers that happened. And so this all of a sudden, just starting April 1st, we had these closed contracts, and all of a sudden pricing rose by 30 to 40% because of this lawsuit. So it's involving a majority of the solar manufacturing countries are in the Southeast Asia region. So President Biden earlier this month delayed the lawsuit by 2 years. So essentially, he's trying to help promote cheaper means of solar purchasing to get back in through the United States. So that's buying us more time, it sounds like, to transfer offshore manufacturing for solar to help try to have more domestic manufacturing, so we don't realize these high expensive taxes and fees that are coming from this lawsuits. So I never want to say that now is the best opportunity. We do see a lot of rebates, grants, and incentives that are happening right now. So a lot of the time is when we already have mass adoption, there's no need for grants, rebates, and incentives. So right now we're trying to essentially we're trying to motivate the economy and the people to adapt this different energy sector through rebates, grants, and incentives. So what that means is within 24 months, the price of solar essentially is going to be rising by 30 to 40%, at least right now. We are going to make shifts to have more manufacturing in like the United States and for NAFTA agreements, but at least that's currently where we're at. So what we've done, so we've created we say it's a state-of-the-art energy department. And so what we try to create is an energy project one-stop shop to get what you need on the material standpoint, but also from the engineering, the design build, the consultants, procurement, and the construction aspect as well. So now it's not just like, okay, now I figure out my EV charging. Now, how do I get the software? Now, how do I get the production? How do I get the battery storage? So we try to consolidate all of that to essentially try to have that one point of contact to help influence these projects. We're lucky enough to win a couple of awards over the last couple of years for what we've been doing. So TED Magazine gave us a couple of awards over the last 2 to 3 years, and actually won again in last month. We had over $70 million in energy projects in 2020. That number rose pretty fast in 2021 to around like 120. So we're growing, and as this economy is growing, there's a great opportunity. And with that opportunity comes with, I wrote a couple articles and columns, so just to create a little credibility out there. So with this opportunity that's coming now, we have this big investment that's flooding in for these type of opportunities. So yes, we're investing into it, but the great thing is there's an ROI. We get able to get a return on investment. So we can help stop the glaciers from melting up north, transition our energy and economy, and from a private sector perspective, we can make a lot of money doing it. When we're able to reach that return on investment standpoint, the numbers that we see that these companies can make are 7, 8 figures easily. It's very, very lucrative for us. So it works out greatly from a capitalistic standpoint, but also the betterment of our society to help stop global warming. So we're OneSource for Power Sonopar. We are the largest distributor in the world. We're global. So we're operating in 48 countries. So when it comes from a standpoint of where we can operate and do business, there is no limit. So we focus a lot on the energy industries, the utility industries, the industrial industries, and also new construction, commercial industries as well. And we have many branches here located in the Pacific Northwest. So we have a lot of branches in Oregon, Washington, Montana, and in Idaho. So for people that are local here, we are local. We do have a local presence in majority of states inside the country. So we've done a couple of projects, past projects. I like to talk about just a couple of examples. It was pretty neat. We had a customer that just wanted to hey, I want to we just want to be the largest EV charging city in the whole entire country. So we designed a nice little 50 kilowatt charging stations for them to have that and offer that. It was kind of more of a standpoint of we wanted to show it just as a branding perspective. There's many different other incentives that are out there. Transportation authorities. So, and I mentioned that project with also we're going to demand 1.5 megawatts worth of power instantaneously. There's many different things that come to designing a charging station for a specific fleet or a specific vehicle. So sometimes someone can go, I want to purchase a 100 kilowatt charging station, but that truck or that vehicle is not capable of handling 100 kilowatts worth of juice. So sometimes the investment into the infrastructure could be completely overstated depending on what type of vehicles that we're looking for. So when it comes to the batteries, there's a lot of like current limiters inside of these batteries, these car batteries, truck batteries, different voltages. So it's important to know that we have these different variables inside of these vehicles to essentially design the charging stations absolutely correctly. A winery was pretty cool. So in California, and I think it's only in California for now, but we have a lot of fires that happen almost every single year. So now from the fire perspective, the utilities can shut off the power in that area whenever they would like. So if you have critical loads and critical batches and you need continual power, if they turn off the power, it's tough. It's a struggle. So one of our favorite projects is, I like Paso Robles Cabernets, red wine. So we're out in Paso Robles, and essentially as they're fermenting their wine, the utility shut off their power. And so now we have this whole batch, and all of a sudden we're trying to ferment our wine, and all of a sudden, boom, gone. So we developed a nice little microgrid solution, a solar battery. So now they have continuous power to decrease the risk of these shutdowns, and all of a sudden, what are they going to do with their batches? And like on more of a sales technique or approach of what products that we focus on. I mean, there's many different ways to become sustainable. A lot of the core resources or the products that are available are more on the solar side. Lighting, of course, our philosophy is reduce that energy as much as possible. So let's reduce that energy with LED lighting. It's the fastest way to get that's also a fast return on investment as well. It's a low hanging fruit. And then essentially after we reduce that energy footprint, now let's go ahead and design an renewable energy footprint to provide power for you. Because essentially if we don't do the lighting first, we're completely oversizing our solar and battery potentially. And that's a lot more of an upfront cost investment. HVAC systems. Now there's coming out with much more energy efficient HVAC systems. So that significantly reduces the energy demand that you need. We'll type microgrid, solar and battery combinations, carports as well. What if we don't have the rooftop availabilities? Of course, we can put it on the ground, different ground mount solutions, and of course, raise certain structures to make sure that we can have solar that's available. And rebate consulting and management, as we talked about during Ashley's presentation. I mean, it is very crucial to know exactly what rebates, grants, and incentives that are in your area to help reduce the cost of investment. And it is very needed to know of what is available, because a lot of these rebates, essentially, you have to design these products to a certain size to get these rebates and grants. And if you miss that, you could be you could be having the expectation that, oh, this grant's going to give me $300,000 for this project. But if it's not sized appropriately, then all of a sudden you don't qualify for that rebate anymore. And it's really, sometimes these rebates are tedious, and it has to be someone to invest into the actual management and essentially to see that process through. Battery storage in the state of California, you get half a rebate up front, and that's based on 5 performance payments to ensure that battery is being used appropriately. Because of course, the government, essentially, that when they want to allocate these resources, they want to know it's being appropriately and basically being used where they think it's going to be used appropriately as well. Let's talk about essentially what we do it's important. I showed this picture right here as an example of a building that we've done to essentially have a design. So step 1, we're gonna have to have a solar design. We're gonna have to have a solar footprint of where we're gonna put this solar. And of course, we're gonna have to model it. And then once we have that model, now we can start having the expectations of what is gonna be our ROI? What are the financial metrics that are gonna be tied to that? But there's also many different parameters in certain different districts, essentially, for utilities. Some people have different fire codes. So in the state of California, solar panels have to have rapid shutdown. So that means the panels have to be shut down at an individual level. So that requires a different inverter. So that inverter at the panel level has to be turned off instantaneously if there's any fire hazards. There's a couple of different, so with a solar system, we have the racking structures, and then we have the inverters, and then the solar panels. So solar panels are produced at a DC power level. When it comes down to a building right now, the power we're consuming right here is all AC power. So that power that's being produced from the sun has got to be converted to AC power. So it's important to know from a battery storage standpoint, a solar standpoint, that you're going to get around, we like to model 15% power loss to be safe. So when you're transferring that DC power to become AC power, you're going to lose around 15%. So so it's important to have that as an expectation, especially from a citywide or a utility scale. We need to make sure that we know exactly how much power we're going to be producing, or else if we don't, that's a big problem. So I mentioned codes in different jurisdictions. So this one's in, I think it's in Los Angeles Department of Water and Power area. And so you have to have 4-foot setbacks away from the roof. So how close can the modules get to the rooftops? There's HVAC systems on top of the roof. Some jurisdictions go, you need this amount of space to have maintenance to essentially get to those HVAC equipments to do repairs. There's many different factors that need to be taken into account as we're going through these different projects to essentially get them approved. Also, like, this is a new emerging market. We have new emerging technologies. EV charging, battery storage, solar hasn't really been existing that long from a application standpoint, from actually coming to from mass adoption. A lot of the engineers that are going through the fire codes and plan checks have never heard of it. And so it's important to know that we have a lot of the T's crossed and the I's dotted as these projects are being submitted, because the engineer, when someone doesn't know something, they're just not, it wasn't me, I'm not going to do it. So sometimes all of a sudden a scary project comes, like, oh, I'm gonna do a battery storage with a 50 kilowatt charging station. It just sits. And so it's appropriate to make sure that everything's been done appropriately right away to make sure that it gets passed through an easy process. Because if any fire codes that come about for, let's say, a battery storage project, that could add another 3 months when someone goes, oh, nope, you missed something. Now you're back in line. It goes your project goes below the paper stack, and it could be a very long process. Consulting and design. So it's important too as well. So we do a lot of consulting work. We had an opportunity with one of the largest cities in the country. He just goes, Corbin, the mayor just dropped, he wants me to do 5 zero net energy buildings. He wants me to retrofit all of our waste trucks to become electric and our city vehicles to become electric. I'm the head architect of this whole city. I have no idea what to do. And so we have these goals, and it's not been established correct. I mean, there hasn't been that many best practices on how to make it all happen. So we do that and come in to help when it comes to how much power do we need, or if that's a power capacity, what size vehicles we're trying to retrofit to make sure we have the correct, appropriate EV charging stations power to make sure that, hey, if I can go 10% to 90% to charge that battery, I can get your trucks and buses out of that lot in 2 hours and 56 minutes to make sure it goes back onto its routes. And of course, there's also space dimensions and size parameters. So a lot of these type of products also comes with that, and to make sure that all of a sudden we go, let's do this, and then boom, there's no place to put it because it doesn't meet fire codes, or there's not enough we oversized the system that we thought it was going to be.
Well, one thing I just want to point out to everyone, you can all share Corbin's passion for this. Let me just see if there might be a couple of questions here. Just want to go back to that consulting slide where you put up about what you do, because this came up before.
There we go.
So the other thing I just want to point out, this is why we like working with OneSource. It's twofold. There are a lot of distributors who can provide product, but the good thing about OneSource is they can manage the project, provide the product, and it's very valuable because they're not just moving boxes, they're actually making it work and invest in your project, which is a very unique skill set versus other companies who simply provide the product. The other thing that I think is also relevant is all of you are looking at implementing all of these great solutions, is that there is a tremendous supply chain issue. So what do you deal with that? Like, how can you actually get the product? The advantage, again, of working with OneSource is being part of Sonepar, a $30 billion organization. They also have leverage over the suppliers, as in many cases, one of the largest customer for all these solar panels, for all these batteries. So when these suppliers are trying to figure out, well, where do I ship a limited amount of goods with a large amount of orders, more often than not, that product gets allocated to OneSource because of their credibility. So those are a couple of things that I independently seen why I like having Corbin and the OneSource organization back these Angel Bee programs, is they've delivered for many organizations. And well, I just want to also check to see if we've got any, we've got a couple of questions here, and maybe Corbin, we could go through this. do you see more DC products? Seeing if there's a lot of Electrify America's building. We'll have to talk to them. I'm an Electrify America customer.
Oh.
And so why don't you talk, one question that Curtis raised is about DC products to reduce the conversion loss. Maybe we'll do that and then let you get right back into your passionate discussion here.
Absolutely. Yeah. Thank you, Ron. Yeah, for that, we do. So yeah, we're a global company, so we do have the great relationships with those manufacturers, and part of that is, it's also very important too to not be tied to one manufacturer for a project. There's many different software applications that other manufacturers can provide, regardless of that simple, actually tangible product manufacturer. I've been asked multiple amount of times, like, can we do a cookie cutter solution? Can we take one, take an idea and then use that multiple over times before? But every product is different. Every building has a different way of how they use energy. Every building has a different amount of how much power capacity do we absolutely have. And so, Curtis, I do see your question. Will we see more DC products in order to reduce the conversion losses? Absolutely. When it comes to a fast charger standpoint, so right now, a lot of the DC products are 24 kilowatts up into, they have 350 kilowatt charger stations as well. Those are all direct current. And I think it's a great point. So the batteries inside of our vehicles, they do accept DC current. And so essentially, if it's an AC charging station, there's going to be more power loss changing that AC to DC to allow that vehicle to charge, because that vehicle has DC power inside of that battery system. Great question. Thank you for that. Okay, let me get back. Oh, it looks like our presentation's frozen again. Okay, yeah, so I mentioned before, any type of project that needs any type of help from either just just need information about material, or if it's exactly specifically sizing equipment, that's where we're more unique, as we do like the design build. Ron, looks like we're frozen up again.
I just need my magic finger to like unfreeze it or something.
Must have said something you didn't like or something, I guess,
Yeah, let me just do this.
Do you provide financing or?
We do, absolutely. And I'm gonna cover that in another slide.
Yeah, you're okay?
Yeah, good.
Okay.
Cool. Yeah, and so we discussed this picture as well. We have to figure out, exactly how much solar or how much energy equipment can we put on our facility, and that's where the modeling comes in, where it's actually crucial to make sure that we're trusting a company or someone that's hired on our staff, or your company staff, to model that building profile effectively. Essentially, if we're over modeling it, where it's going to be more power than we expected, we're not going to receive that ROI as fast as we thought we were going to. So market forces. We know the White House has allocated over $500 billion to upgrading the power grid, and also to add 500,000 electric vehicle charging stations. So as we know, this market is here, and it's absolutely here to stay. And we're at the ground floor of it, which is really exciting. And to kind of give some insight, in the beginning of 2020, during the COVID year, this is by Bloomberg, that $117 billion was invested into the renewable markets. By the end of 2020, that number shot up to $700 billion. That's during a COVID year. So that just shows exactly like how far and how fast this market is moving, how much momentum it's gaining, how fast it's growing. So battery storage. This is like a newer type of concept. Battery storage it's a way that we can control power. If we're adopting a full solar energy system, what happens when the weather is not good? What happens if we're having some outages? How do we have productive, tangible power where we can actually control it? Because sometimes the solar aspect is only dependent on the weather. That's where battery storage can come in. So if we oversize that solar, we have excess solar, the solar is going to charge the battery, and now we can release that energy whenever we would like. So I've heard a lot of conceptions where it's like, hey, I want to have a huge 150 kilowatt charging station be all provided by solar. Well, to kind of we just did a project out in the Caribbean island where it was 1 acre equals 800 kilowatts worth of solar. So if we're talking about 150 kilowatt charging station, do you know how much solar that is needed, how much land that is needed to actually have the solar energy that's going to be appropriate for that charging station? So that's where battery storage comes in as well, to make sure we have reliable power for those charging stations, so our electricity bills don't skyrocket up when we're demanding a lot of power from the utility. So battery can be charged at night when energy is cheap, and we have that power readily available for during the day when we're ready to use it. So this is a little cool chart that I found that is supposed to be the growth of battery storage. It's supposed to rise over 18,000% over the next 30 years. And so it's no coincidence that battery storage is becoming popular, and also electric vehicles is becoming popular. It's similar to this, it's the same technology. It's becoming more efficient for the space efficiency, and also is becoming more powerful for that efficient space as well. So now we're starting to see on a regular electric vehicles, that we're getting our 200 to 300 charge range times as we're driving. Innovative solutions. So like it's a lot of it I mentioned before. Solar mainly is the solar panels. And then we also have the inverters. That's basically transforming that power from DC, where it gathers from the sun, transfer it as AC power that we can use at that facility, but also the racking structures. So of course, where are we going to put it? There's many different innovative ways that where we can do it. Of course, with solar panels, we have parking spaces, and if we're for a profit entity, if we're a profit business, how can we maximize our revenue per square foot? We have all that parking space that's not doing anything. It's just allowing us to just park our cars there without returning a revenue or anything like that. Adding carports with solar on it, we can get an ROI. We can get a return on investment on that system. And again, too, it's just because we have HVAC, we don't have a large roof mount space. We can alter and manipulate the racking systems to raise that above certain HVAC and mechanical systems to allow us to put solar on certain buildings. Especially when we're downtown, it's a lot tougher to have that roof space. So we have a couple of past projects that's pretty neat. And we had a utility that's asking for, we wanted to have a microgrid for a specific area of our community. And I think we talked about predictive analytics and artificial intelligence in the last one of the presentations that we had. So it's pretty neat. We had to design a battery storage system that basically had artificial intelligence that could predict weather patterns from up to a week's time frame. So that way it can essentially control, I've mentioned before about solar is uncertain because of that the weather patterns. Now we have that, and now we can act accordingly of how much power we need to store inside of our battery systems. So there's many ways that's ways around these hurdles. That's why it's also, we say it's important to, on a sales aspect, from our company, our firm, we're able to know all these different products, all these different manufacturers that are available to provide these for one complete solution for these opportunities and these applications. So microgrid, what is a microgrid? I try to bring it down to like almost as simple as I can. It's having the ability to have a grid and power in a centralized location. So instead of demanding it from the utilities, we could create a microgrid for. We're in a hotel that we're present here. How can I create this hotel be self-reliant on its energy infrastructure, that it doesn't have to draw power in from the utilities? So there's a couple of forms. So grid tied is essentially you have this energy ecosystem. You can have solar, battery, wind, cogens, generators, and all these systems are working together to create power for a facility. So a microgrid essentially is like, all right, what is the cheapest way to use power? And then which energy asset do I want to use that power? So we say we got wind. Wind's the cheapest option to use power right now. Let's close that circuit. Now let's use the wind power. Let's open the other circuits up for the solars and the battery storage. We're not going to use that right now. So it's always a constant dance with software platforms to know which energy generating asset we want to use. So you could do that and tie it to the utility and still have that be there. So you have all these different assets that still tie to the utility. That's a microgrid as well. But the most common one that we hear is we want island. We don't have to be islandable. We want energy independence away from the utility. And so that essentially is an islandable microgrid. So there's two different aspects between it. We're still connected to the utility, but we're also separated from the utility. The values of it, there's increased profitability. It's a lot longer of an ROI if we wanted to be strategic of having solar and battery storage for a financial play. Of course, we have to oversize it where we make sure that we have reliable power infrastructure for a nightly basis. We have energy resilience and reliability. We can actually rely on that energy that's available and not have to worry about fire codes shutting off our power, weather patterns that's going to shut off our power. We have reliability for it. And of course, sustainability, which is going to be a beautiful thing to help provide power for all of our different buildings and opportunities that are out there. That kind of segues into this slide. There's a lot of, unfortunately, we have natural disasters in California where the fire codes come in. Microgrid mitigates that. we have floods and hurricanes like, unfortunately, in Puerto Rico, Houston, New Orleans. Having a reliable infrastructure and that way can help these cities bounce back faster and not to rely on or being out of power for a couple of days, which causes it to be quite a strain on just business operations and how the city operates in general. I mentioned before, solution, a lot of it's solar, battery, wind, generators, co-generators to make this all happen. Here's the diagram that we do. We'll show our customers exactly what that looks like. And so this is an example of a solar and battery diagram. So this customer has this is more of a return on investment type of play. And so this diagram shows when we're going to use battery storage. So the light blue shows the solar production during the daytime. So essentially we oversize that to charge the battery storage. So this customer has substantial, gets peak charge from 4 to 9 o'clock p.m. every single day. The prices go up by two and a half times. So now we designed a battery system that's charged by solar to release during that 4 to 9 o'clock. So they don't have to realize those high energy charges during their everydays. And so, yes, we do finance it. So there's many different financing opportunities that are available. A lot of PPAs is the most common one that we see, but we like to recommend other different financial instruments. There's different ways where, you can formulate the financing for customers to fully own the equipment and pay off like on a semi-annual basis. But this way, we talked about real estate, how commercial real estate companies want to increase the value of the property. The solar and battery increases it immediately. Also, you get the rebates, the grants, the incentives, and also the lower energy costs that come with having the solar and battery energy. There's many different strategic means that we could utilize together, try to figure out what's going to be the best solution for that. I think we went over, we're unique at OneSource. We're fully vertically integrated as we're talking about. We do every project designed by hand. There's a lot of software programs that try to, just design these projects. There's a lot of variables that we found within our experience that is not telling the whole story. So we want to tell the exact story and be as accurate as possible when we're doing these type of projects. When we have an 8-building campus that's relying on the energy resources that we're designing, it's very important that we have that be correct. Okay, so a project. So what does the project look like? So now we know we want to do solar and battery. We have these ideas. Now, what does it look like? Now, how do we get started? How do we get rocking and rolling? So first step, we need to gather data. We got to see what we're looking at. We got to see how much electricity is being consumed and by which meters. What are critical loads? What are not critical loads? When are you using your energy? So we've seen a lot of companies say, here, can you help us out? Here's our KWH, how much KWHs we're using per month. And I go, that's great, but what if you're using all those KWHs during the nighttime? So if we're trying to do solar, that solar is going to be irrelevant because the solar is going to offset that energy that's being demanded during the day, and also KW. And so essentially it's KWH, a lot of on the energy bills, there's substantial charges for the KW rates. So we need to see exactly when each building consumes power. Is it mainly from an industrial standpoint, are we turning on the equipment at 10 o'clock and that equipment is running from 10 to 12, then that's where the pain of all that electricity generation is coming from. So we need to target our sizing for those specific times. So it's important to know, when are we using that power and how we can offset that power for specific timeframes during that time. And we got to create our concept. Is it just fast ROI, a fast offset? Is it going to be a sustainability measure? We need to have 50% of our power consumption be off of clean green energy. Or is it a microgrid? So we have to work with our customers to figure out exactly what that is. And now we create the design. Now I got to take this design and make sure it's engineered appropriately. Electrically doesn't make sense. Structurally doesn't make sense. And civilly doesn't make sense. So now we have all of this come together. Boom. Now it's time for a project. We can submit the projects to the city for the plan checks. If we have these things all appropriately designed correctly with the correct engineering, confirming our designs, hopefully we don't get any call outs going through the utilities and through the cities, which is always, you never know. But yeah, now it's after we have that, now it's time to procure. Now trying to plan our lead times together, try to get our equipment and also construct it. Make sure that we have our products that are available, ready for the contractors, ready to start the building process. And then of course, post-project support, and then of course, gather that funding that we've been talking about from the rebates and grants. Once we have that project, we can start getting our money that we're expecting. Okay, so we have all of our energy information. So we got to find a facility, gather all this information, see when they're using their power, during what timeframes, what are those prices during what timeframes, during certain months or not. And now let's start sizing out that solar system in our battery system to try to get either the most sustainability as possible, or also to get the fastest ROI. We need to have a picture into the data inside of that building. And of course, we talked about rebates, grants, incentives, how important that is to gather all of those different opportunities that are available and make sure our design is absolutely appropriate to be able to achieve the rebates, grants, and incentives for it. And also to show the economics, what does that look like? So essentially, if it's going to be a $3.2 million project, what type of solar incentives are out there, what rebate programs are out there, and how much can that bring down our cost of investment into these projects? So for this project, we are able to bring it down to $1.8 million based upon the rebates and incentives that were out there for these customers in this facility's jurisdiction. And like I mentioned before, there's only going to be a small window of how much of this funding is going to be available, so we can realize these financial gains. So this is another example. A customer wanted to, so a word of advice: just because a panel is a higher output panel doesn't mean it's going to be the most effective for you. So essentially, if it's going to be a 500 kilowatt or 500 watt panel, that could just mean that it's much bigger than a 400 watt panel. And so essentially, as we're putting it onto a rooftop, we need to make sure that we have the highest output module with the smallest space, so we can achieve the fastest energy production as much as possible. Of course, we have carport design implementation. We can essentially get steel structures and steel beams. We need to make sure that we have our seismic calculations. We have our structural calculations, geotechnical reports as well, to know exactly what is the dirt, or what is the grass, or wherever we're putting that. How can that structure be held up? And then we add the solar modules on top of it. We mentioned before, ground mount. There's many different opportunities to get creative, to put it over a reservoir in the middle of the agricultural land in California. There's many different ways that we could do this, as long as
design.
Isn't it pretty sweet? Yeah, it definitely is unique. Just having the steel structures to make it all work.
It reduces evaporation.
Yeah. Battery storage design and implementation. So a lot of it comes in 10-foot, 20-foot, or 40-foot containers. So imagine like a container, on the back of a truck. Of course, it's painted, it looks well, and battery storage goes in. So there's different battery cells, racks, and cabinets that goes inside of these systems. So we always advise that if your customer is interested in battery storage, if we put it inside the building, a bunch more fire codes pop up. That's basically fire codes, building codes. That battery has to be essentially all the building codes apply when it goes inside. And if we put it outside, we don't have to worry about building codes. So it's always a lot more easier to get processed and for that project to go through when we're essentially designing that system to go outside. A battery system, we have to have HVAC on it to cool down the batteries, because we know if batteries heat up, we lose power and efficiency. And also an inverter, same logic, but with the solar as well. We store it as DC power, and we have to bring it to our use case in AC power. As a couple of functions for battery storage, if it's going to be demand charge management, let's say a manufacturing facility turns on their equipment around 10 o'clock, and that all this high power is being used from 10 to 1. And then essentially that load demand drops all the way down by 50% during the rest of the day, no matter what the high point of power that we're generating, that's going to be our cost for the whole entire month. So we have battery storage. We release that energy during that time. It brings it down, so we can have a levelized power output to realize substantial savings. Time of use management, we mentioned before, like if our energy structure is under time of use, and our costs are rising by 2 to 2.5% during 4 to 9 p.m., a substantial savings. But also, I think an underrated factor is, as I mentioned before, is PV smoothing, solar soothing. This way we can have a predictable amount of power every single day, that we know how much power we're going to have for our applications. Here's just a cool, just little specs of what it looks like inside. We see here's the container, what it looks like. And on the outside, that's the HVAC equipment to keep the batteries cold or cool. And if you look inside, so the picture below that those are the battery cells. So you have cabinets and just a bunch of battery cells all stacked with one another. You string them together, and that's how we're able to have them conjoin as one full entire system. It's important to find a full turnkey solution provider. Because like I mentioned, there's a lot of different products that go with the battery storage application to be able to have that. And that's only for the hardware, but there's also software. So now how do we commission it? How do we control it to the application that we want? And it's a lithium iron phosphate chemistry inside. So what's the great thing about lithium iron phosphate is that it's lower cost with high power output, and it's also very safe. So of course, stored energy, if you lost stored energy in a certain area, it potentially, that's a dangerous situation, but the safety requirements that goes into it and the safety investment around it is extremely important to make sure that we can rely on it. Here's an example of the different use cases. So the one up top is that this is like a very conservative peak shaving opportunity. So essentially that blue is what is before battery storage. So now we're paying these high rates at that blue. Battery storage can just bring down that mountain. So smooth it off so we don't reach these high prices. And the bottom again shows the time of use. So that's what essentially when we're being charged a lot of money during 4 to 9 o'clock, the battery is being released during that time frame to give us our savings. Here's like an example. Here's a single line on how it would work. So essentially we have the E-gauge meter. So the meter is telling us when we're, or how much power we're using, but also when to release the power from the battery system to get the expectations that we're looking for. So that E-gauge meter is going to talk to the energy management system. So let's say we have it for peak shaving. So we have 80 kilowatt. So we want 80 kilowatts at the facility, but if the facility is demanding 100 kilowatts, that's when we want to use the battery power to essentially offset those 20 kilowatts. So that E-gauge meter will talk to the battery storage energy management system, and that's what will tell the battery to essentially release its stored energy into the facility. So we have our circuits closing. It goes through the battery says release, circuits are closing. It goes through the inverter, it gets transferred from DC to AC power, and then it goes essentially to the AC panel. Now we have usable power from that battery storage unit. EV charging fleet design. So we're getting to some products. There's many different solutions that are out there. A lot of the smaller ones that we see are called level 2 stations. And these are pretty agnostic for electric vehicles. Teslas come with an adapter to be able to use these AC stations. But where it gets a little confusing is on the DC level with the higher powered stations. So they come with 2 receptacles. So basically, essentially, the configuration on the charging port where you're putting it into your car. So there's CCS and CHAdeMO connectors. So as you see here, there's like 2 different cables on those larger charging stations. That's for one CCS cable and one CHAdeMO connector. So CCS has mainly been for North American and European cars. So any Asian manufacturer cars or Teslas use the CHAdeMO connectors. So we're starting to see this, it's slowly starting to shift, like a more industry adoption and standardize to CCS, but it's not fully there quite yet. So here's an example of what a level 2 station would look like from a manufacturer like Siemens. There's no screen on this, so it brings the cost down. In the state of California, you have to have a screen for new construction charging stations because it's a way to measure how much power is being output and how much you're charging customers. So there's new codes and regulations are being put on what type of charging stations you can build for new construction opportunities. Here's one with a screen, what this looks like. And so these chargers price range are around $3,000 to $7,000 for these type of level 2 charging stations. And we're going to get a charging time from around 4 to 6 hours, basically, is how long it's going to take from full charge. So when you go to workplaces or you see these smaller charging stations, these are the ones that you're seeing. ChargePoint's also a well-known manufacturer. They do hardware and software themselves. That's where they're able to increase the prices for it. But there's other options too, where other manufacturers are much cheaper and you can provide other software platforms too. Here's a really cool, we actually stock Abb Fast Chargers, and which is unique about us. It's a 9-month to 1-year lead time. And so we do have these in stock ready to go, which is unique. So 24 kilowatts is that wall box on the left. That's going to be around $15,000 to $20,000, and you'll get a charge between 2 to 3 hours. A 50 kilowatt charging station is going to be around, let's just say like $45,000 basis. And that's going to give you around a 30-minute to 1-hour charge time frame. So now there's new charging stations that are coming out where so before fast chargers, you couldn't have 2 cars pull up to one station and have the power be split into 2. So now that it does exist where you can have a fast charger charge 2 cars at the same exact time. So these range from 94 to 184 kilowatts. So if we're going to get around 120 kilowatts, that's going to give us a 20-minute to like a 40-minute charge time frame. So if we get to the 180 kilowatts to 200 kilowatts, we're going to be under that 15 charge time window. But again, that's a lot of juice and a lot of power capacity that's needed for it. So we have to keep that in mind when we're thinking about implementing charging stations for our facilities. These are different charging strategies that's available. Sequential, it's kind of one after the other. Concurrent is just always going to be divided by 2, so it's going to be 50% of that charging station rating. Or you're going to have dynamic, where we're going to have that charging station. No matter if one car is pulled up, it's going to be a full 100% charge. If 2 cars are pulled up, now that power capacity is divided by 2.
Do more than 2 or just 2?
For one station, at least right now, they just have 2. But again, that technology just recently came out for 2, so which is actually it's pretty cool. Here's more for the fleet charging scales. So the one on the left is these are like 150 kilowatt charging stations and above. A lot of public sectors have used the one on the left, and that one is you have one power. The reason why it's so valuable is you have one power cabinet, but you have 3 charging posts, so you can have 3 trucks hook in at one time, but sequential though. So it's like 150 kilowatts, and then when that's done, it goes to the next bus, then it goes to the next bus.
I've seen power profiles are high when you first charge and then you taper off, at which point you should be able to put on another charger.
Mm-hmm.
I was only metering level 1 and level 2.
Okay. Yeah, there could be different controls that you can control the software program to do something like that.
Yeah, these were just what I saw in my meters. That's all.
Mm-hmm. I already just went over that, and the software is important as well. So now it provides charging transparency. It gives us the ability to upcharge for electricity. Let's say electricity is 14 cents a kilowatt hour. You can charge for anyone using your charging station 18 kilowatt hours to use that charging station. So you can build revenue over time. Also, the software creates a dashboard through applications, so people can see that our EV drivers, they can see where your cars are. So this creates a marketing opportunity for people to come into their stores to have charging stations. Oh, I can charge. Now I can go in and shop while my car is being charged. Part of the reasons why we're seeing a lot of, Electrify America is putting a lot of these fast chargers into these shopping centers. They did a study that it was like almost for an EV driver charging their car, they spent over 90% more waiting for their car to be charged inside of those super centers. So it's been a big incentive for them. You can control the load. How much load you want those chargers to charge. So in case there's any specific time frames where you're being charged a lot for electricity, you can bring down that load by 25% to make sure you're still under the energy consumption rates, not be drastically charged for charging stations. This kind of is more like an example of what the app looks like. You can make reservations on your phone. Of course, you put in your credit card, and then essentially you put your charging station in it. You hook up your charging cable to your car. And of course, when your session is over, it will charge your credit card for the payment method that you would like to use. Here's an example. We talked about CO2 saved. A couple of these software platforms show that by the charging sessions. This one use case example is from 176 pounds was reduced because of charging stations. It shows the revenue that was generated from that site from people using those charging stations. It also shows the total energy output that was used as well. So the software provides full transparency and also controllability within these charging stations. And that's pretty much it.